Okay, let's dive right into this explainer and set the tone for mastering your Cambridge Computer Science exams. Welcome to the boardroom. Today, we are not just passively studying, we are strategizing. I want you to look at your exams, whether you're working through the IGCSE syllabuses like 0417, 0478, 0983, 0984, 2210, or you're stepping up to the advanced A-level 9618 as the ultimate corporate pitch. Picture this. You are the lead consultant, the Cambridge Examiner Board is your most important client, and your exam paper, that's your multi-million-dollar proposal. If you want to secure that top grade, you have to justify every single point with hard data, crystal clear logic, and undeniable strategy. Today, our focus is going to be on a notoriously tricky past paper topic that catches so many people out. We're talking about optical disc reader and writer principal operations. We are going to completely deconstruct exactly what those senior examiners are looking for, and more importantly, how you can deliver it to them flawlessly.
Now, what's really interesting about this is just how much weight this carries. This single topic accounts for a massive 15% of your paper 2 marks. Just let that sink in for a second. 15%. In the grand scheme of an intense, high-stakes examination, 15% is literally the difference between an average, middle-of-the-road grade and a top-tier result. It's the leap from a B to an A or an A to an A star. When you walk into that exam hall, you absolutely cannot afford to leave these marks sitting on the table. But here's the crazy part. Year after year, the principal examiner reports show that thousands of students completely mismanage this segment. They treat it like it's just a simple memory test. They just try to recall facts rather than treating it like the analytical challenge it actually is. And because of that, they leave massive amounts of points behind.
So, we're going to treat your exam like a strategic corporate pitch, and here is our agenda to prove your methodology to the board today. First, the 15% challenge. Second, the top examiner pitfalls. Third, the method mark strategy. Fourth, our critical analysis matrix. And finally, the winning blueprint.
All right, let's jump straight into section 1, the 15% challenge. Now, you might be wondering, why do so many students drop marks here? Well, the difficulty isn't actually that the underlying technology of optical discs is impossibly complex to understand. The real challenge is in the translation. It's all about how you translate your raw textbook knowledge into the highly specific format that the Cambridge assessment objectives demand. Think about it. When you step into a boardroom, you don't just dump a massive pile of raw data on your client's desk and expect them to be impressed, right? You have to synthesize it, you have to structure it, and you have to make it directly relevant to their specific problem. That exact same principle applies to your exam paper.
To understand this better, we have to look at the assessment objectives. These target 3 distinct cognitive domains, and they strictly prioritize analytical depth over superficial breadth. Knowledge and understanding, that is just your baseline. That just gets you in the door. Application allows you to use your formulas in context. But analysis, this is where the real heavy-hitting points are won. Analysis requires logical reasoning. The examiners don't just want to know that a blue laser has a shorter wavelength than a red laser. Anyone can memorize that. They want you to analyze how that specific wavelength difference impacts the algorithm efficiency when reading highly dense data blocks, and what technical trade-offs that introduces in a real-world scenario. Analytical depth is absolutely king here. Let's look at 2 totally classic student profiles. We all know people exactly like this. And they both lose marks because they lack structured, logical reasoning in their pitch. First up, we have Alex. Now, Alex has literally memorized the entire textbook. Alex writes 3 incredibly dense paragraphs about polycarbonate layers and spiral tracks, completely overloading the answer with raw computer science facts, but offering 0 actual analysis. When the command word explicitly asks to evaluate, Alex just describes. Result? 0 evaluation marks. On the flip side, we have Sam. Now, Sam actually knows the material but rushes through the paper and completely misses the command word requirements. If the question says compare data transfer rates, Sam just lists the different rates without ever actually drawing a comparative link between them. In our boardroom analogy, Alex bores the client to tears with trivia, and Sam completely ignores the client's actual question. Neither of them wins the pitch. But we are going to fix that by mastering the Peel framework. Point, evidence, explanation, and link. Transitioning over to Section 2, we're going to dissect some direct warnings from the principal examiner reports. These are the people who actually mark your papers. So when the senior examiner speaks, we need to listen up. Let's pull back the curtain and look at exactly what goes wrong for candidates year after year. Okay, these are the top 3 absolutely crucial mistakes candidates make, particularly when they're asked to evaluate algorithm efficiency or hardware operations. First, using the wrong formula or algorithm for the specific context. This looks like using a generic storage calculation when the exam scenario specifically involves error checking overhead in a dual-layered disk. Second, forgetting to check boundary conditions in edge cases. This is huge. What actually happens when the optical reader's laser transitions from the first layer to the second layer? Those edge cases? That is exactly where the A-star marks hide. And third, providing generic answers that are not specific to the given scenario. I'm telling you, this is the deadliest trap of them all.
Notice the massive transformation here. The generic syllabus answer says something like, optical discs use lasers to read data. Sure, that's true, but it's basically worthless in an A-level context. It earns red marks. But look at the context-specific pitch using our PEL framework. It says, in the context of the hospital's high-speed archiving requirement, the Blu-ray drive's shorter 405 nanometer laser wavelength allows for smaller pit construction, thereby increasing the data density to meet the 50 gigabyte daily backup threshold. Wow, see the difference? Point, evidence, explanation, and a direct link right back to the hospital scenario. That is exactly how you turn those red marks into green check marks.
Before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Let's dive into Section 3. This is the method mark strategy, and it's your ultimate safety net. This is where marks are won through your process, not just your final answer. If you just magically write down the correct final answer at the bottom of the page without showing your procedural framework, you are going to lose the vast majority of the points. The boardroom needs to see you're working. They need total confidence that your methodology is sound, logical, and reproducible. Let's define what a method mark actually is, because understanding this drastically lowers test anxiety. It means that even if you make a tiny, silly arithmetic error right at the very end of calculating an optical disk's rotational latency, you can still secure 80 to 90% of the total points for that question. How? By proving your methodology. You show the examiner that you know how to deconstruct the problem, solve it systematically, and evaluate those boundary conditions. You aren't just blindly hunting for one correct number, you are building a watertight, logical case step by step. The secret here is managing your time across these 5 procedural milestones. Imagine a 10-minute question. Minute 1, deconstruct the command words. What are they actually asking? Minute 2, extract the data. Pull out those laser wavelengths and spin speeds from the text. Minute 4, select your analytical framework. This is where you decide to use the Peel structure. Minute 7, execute with super clear notation. And minute 10, present your final answer with exact terminology. Don't just say, the light bounces back. Specify that light reflects off the land and scatters in the pit, causing a measurable change in light intensity read by the photodiode. Follow this timeline, and you guarantee a structured answer that hits every single requirement. Stop scrolling. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. All right, moving into our interactive workshop in Section 4, the Critical Analysis Matrix. In a high-level 9618 paper or any of the upper-tier syllabuses, it is simply not enough to just list facts in parallel. You have to intersect them. You have to actively build bridges between the concepts to show deep comprehension. Let's look at exactly how top-tier candidates construct this. This matrix is your secret weapon. Top candidates explicitly map similarities against differences. Take a factor like speed. What's the similarity? Well, both read and write operations use lasers. But what's the difference? Laser power and behavior differ drastically between reading and writing. And the evidence? You back it up with data transfer rates. Now look at capacity. The similarity is the baseline optical media format itself, but the difference lies in layer variations backed by hard numerical storage limits. When you structure your thoughts using a matrix like this, you naturally start using comparative connectives in your writing. You'll start saying things like whereas, or conversely, or in contrast. And that is hitting the exact evidence-based reasoning benchmark the board demands. Let's do a quick find the flaw challenge. Imagine you have a sample paragraph where a student writes, the algorithm spins the motor faster to get data quicker. What is the flaw there? Well, there's absolutely no context, and it completely ignores hardware limitations. Let's fix it using your practical steps. The system must actively regulate rotational speed to ensure a uniform data read rate, especially if the laser moves from the inner tracks to the outer tracks. And what is the edge case we need to test? The transition point itself requires a massive adjustment in motor speed to maintain that constant linear velocity. If you can quickly spot that flaw and write a peel paragraph touching on those exact steps, you are securing maximum marks. Let's bring it all together in our final section, the winning blueprint. We have successfully decoded the command words, we've applied the PEL framework, and we've utilized the time management matrix. Now it's time to assemble your final presentation. You need to show the examiner that you are thinking like an engineer, an analyst, and a boardroom strategist all at the exact same time. These points represent the kind of evaluative thinking required to formulate a recommendation that the examiner literally cannot fault. If a scenario asks you to recommend a storage strategy, you must consider multiple alternative solutions. You might state that while standard DVDs are highly cost-effective for distribution, Blu-ray provides the necessary density for archival. Then, analyze the technical trade-offs, like Blu-ray's higher initial hardware cost. Always acknowledge system limitations, such as the fact that optical media can degrade over time or scratch. Finally, justify your decisions with solid evidence drawn directly from the text provided in the exam. This proves to the board that you see the whole picture. I absolutely love this quote straight from the Cambridge syllabus framework because it perfectly summarizes everything we've talked about today. Rote memorization won't survive the boardroom. You have to be adaptable. Think about it. The exam board might throw a curveball and invent a completely fictional, proprietary optical disc format with a green laser and 3 data layers. If you only rely on rote memorization, you will freeze and panic. But if you have that connected conceptual understanding, if you know the underlying physics that shorter wavelengths equal higher data density, you can transfer your knowledge to that unfamiliar context instantly. That kind of adaptability is the true hallmark of an A-star student. And the proof is really in the results. Students who actively implement these specific computer science strategies see an average improvement of 2 full grade boundaries. That is huge, but that only happens if they practice consistently with our weekly explainer content. Moving from a C to an A isn't magic, it's methodology. It is thoroughly understanding the 15% challenge, avoiding those classic examiner pitfalls, securing your method marks every single time, and applying the critical analysis matrix to build your case. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGCS and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this explainer with a study partner. Ace the Exams. Your Cambridge success starts here.